I just can't help myself. This is a small box for what should be inside. Let's give it a go. You know, it was very cold outside, and I let this stabilize and warm up in the house for 2 hours before we got to this point and opened it. This is wedged in here a little bit. Glass tubes, so be careful. I guess we got lucky, the box wasn't crushed. Not the best way to pack fragile items. You should have an inch or two of space all the way around. And of course, it mostly survived, but these guys were strained a little bit. When you pack stuff, you can't cram it, and you have to support certain things. But we made it in one piece, so I guess I'm happy. So stick around and we'll get this thing fired up. Should be a fun little project. Beautiful. 1971 date codes. Oh, let's look, see if there's anything older than that. Change the glasses. Well, double stack the glasses. You guys might be able to see. Ooh, we got maybe a 1969 date. Get the old Nixie drivers, the 7441s, not the 74 141s. So that's early. I think clamping was something that they changed in those, so you didn't get any cross glowing. That's what the change was about, as far as I know. Looks like the newest ICs in here are 1971, with one possibly older one. Yes, that was probably replaced. That might have been a failure because it doesn't match the rest of these. That was probably replaced. A couple of these may have been replaced. Cool stuff. Yeah. Does anybody know what this is from? Yes. This clock. The guts here are inside there. The B&F Enterprises digital clock kit. This is a very early clock kit. 1971, 72 time frame. Let's see if we can get this fired up. So this transformer is actually in the original design of the B&F clock. We can stick with that. For the sake of getting this up and running, I could have just put basic bench supplies on it, but I figured I'd outfit it with the original style equipment that it would have been built as a kit with. Well, we have this board rigged up. A spaghetti mess. We have all the supporting components, capacitors, transformers, pass transistor for 5-volt regulation, just kind of hanging out. I don't know how long we can run it without a heatsink, but we'll check that out. So this board came to me as an orphan, but I recognized what it was, and I happen to have documentation on it. So we got our high voltage supply down here, and our low voltage regulator and supply here, and I was able to find the points on the board to connect all the stuff up. And we have set switches, actually buttons, kind of hanging out here. There's 3 of them. Seconds, minutes, and hours. A new old stock stand core transformer, fresh out of the box, as you saw. Capacitors hanging out on the back. Well, we're ready. This is a temporary rig, but we get to determine whether or not these Nixies are going to play along. It's been years. We don't know the history on this. Everything looks good from what I could see. I'm sure there's something we missed, but are we ready? Let's do it. And we got nothing. Well, not a Nixie to be lit. I expected better. Alright, well, we're going to have to do voltage checks. So in bringing the DMM out to check our voltage supplies, I started to see a little magic smoke. It was coming from the area of the high voltage rectifier diodes. They were a little hot. I'm not sure how hot they got, but I was able to determine that I definitely had a low high voltage supply before I shut this thing down in a frenzy. No damage was done, but I'm starting to look at the high voltage. There's no direct short on high voltage rail, but I am brought into this resistor here. Is that a 100K resistor? High voltage bleed down. Measures 15K. I can't see the colors. We'll pull it out of circuit and measure it. That's going to be the 170 volts. Take a look. I'm going to do this quick. Yeah, so it's still being pulled down. The logic supply gets pulled down to about half of what it should be whenever the high voltage section's connected. Without the high voltage wires on the board from the transformer, the logic supply appears good. I have traced the high voltage section on this board, and I am not seeing any dead shorts or anything that's pulling it down. I surmised that this resistor was an issue at first. I had lifted that, and that's why the meter actually doesn't go to zero pretty quick, because that's actually a bleed down resistor for this high voltage capacitor. So that's lifted. Nothing's dead to short, to ground. Everything appears pretty good in the high voltage section. I did notice the high voltage rectifier diodes are getting hot pretty quickly. So they test okay with the DMM. I'm going to go that direction next. There's nothing else, at least that I've found. High voltage section, 2 rectifier diodes, capacitor, bleed down resistor, straight through to the Nixie anode resistors. And the colon tubes are also in there with their own resistor. There's no dead shorts anywhere that I could find. These two diodes, I lifted a leg of each, take those out of the circuit, and then I'm going to use a separate high voltage supply, already DC regulated at 170 volts, and we'll inject that at the end of the capacitor, and that should supply the tubes. And then we'll recheck the logic circuit. So this will be high voltage, this will be the 5-volt logic circuit, and hopefully we'll see something on the tubes. Oh, and back here you can see the high voltage leads from the transformer disconnected and taped off for safety. Let's start with logic. That'll be through the low voltage winding on the transformer. So I'll plug that in. Excuse my reach. And okay, so we got 4.6 volts. That's good. And here we go with the Nixie voltage. Oh, there we have it. It's alive. So we have 170 volts, if you can see that here. Our logic circuit, and beautiful. She's counting. She's alive. So what was it? Leaky diodes? We're going to have to look into those two diodes in the high voltage section. So like they're lifted and out of the circuit now. Something was pulling down the high voltage. And because it was on the same transformer at the same time, it would also load down the 5-volt section. Once I removed the transformer from the high voltage section, the logic voltage would come back up. So then I decided, alright, well, let's totally eliminate the high voltage stuff and inject a known good high voltage source, and that's what we're using. Torta Scuba on eBay, the NK01B, 170 volts. Put in a box, very handy. Alright, let's play with, since I installed all these set buttons, this switch down here is a set run switch, so that should stop the count, and it does. And it should allow time setting. I think this one's the hours. 2, 3, 4, 5, 6, 7. Oh, you can hold it. There you go. Oh, and that works beautifully. Seems pretty noiseless, not too much bouncing. Yeah, no switch bounce. You release it. I'm just pressing it into the board, so I can do it one-handed. That's beautiful. Okay, back here I have seconds. All the digits look great. These tubes are the ZM1000R, R for red, and they have some really nice characters in them. And the 5, yes, the 5 is a real 5. Colon tubes are just neon tubes with some sort of a grid to simulate colons. So what is missing is the original enclosure for this. I don't know what I'm going to do with that yet. But first things first, get this up and running. Try and figure out why the transformer was not doing it. I'm going to look into those diodes next. They are 1N 1004 diodes, so they're 400 volt rated. I don't have anything to test the leakage, but maybe I'll just whack another set of diodes in the circuit and see if I can get that transformer to drive the high voltage section. And back running. Let's see. There we go. I like that it's set up for 12 hours already on these B&F kit clocks. Wish they were still around. They have provisions for cutting out traces and adding jumpers to do 12-hour board modifications. So it reworks the logic, and then it counts to 24 hours. So how is our pass transistor for regulation behaving? Thermometer would be smarter. Yeah, not bad. Lukewarm. So that's not having to dissipate a lot of voltage. The transformer has a 6.3 volt winding, rectified, filtered, that comes up a little bit, and then the pass transistor will bring it down to the 4.6 volts, which I think is also adjustable. There's a potentiometer in the top of the board. I can't really see it from this angle, but it sits right back up here, and yeah, so that transistor's not having to do very much work, so that's good. Normally it's screwed to the back of the aluminum case in the original kit design. These are the two high voltage rectifier diodes that I lifted out of the circuit. They check with the DMM just fine. Open one direction, 0.6 the other direction, but they were getting hot. Something's loading this down. There's nothing else loading this down. Something has to be at fault. One of these or both must be leaky. So we're just going to shotgun them. There's nothing else left. This is the bleed down resistor. I can put that back in circuit because that didn't seem to affect anything. Then we'll go from there. So we got the iron transformer wired back in, and the two rectifier diodes I had lifted earlier to get this working. This is one sample. Here's the other one. We took those out, and like I said with the DMM on diode check, they seem to be open one way and then measure correctly the other way. So the only thing left in the circuit was those two diodes. So we replaced them, and those were 1N 4004s, which are good for 400 volts. The last digit 4 tells you that. And I didn't have any of those here, but I did have a 1N 4007s, a pair of those, and they're good for 700 volts. Virtually the same, they'll work. They handle a little less current at 1 amp, but we're not drawing anywhere near that, so we'll be more within our margin. So the 4007s will be fine for this application. What we're going to do is see if that fixed the problem. Here we go. Oh, there you have it. 173 volts, and we have a display off of the transformer. That's it. This thing's up, it's running, it's fixed the way it was intended to be. This big iron transformer in this circuit are intended to be in a aluminum case. I don't know where we're going with that, but for now this video was to take this vintage gem and to get it up and running for all to see. Okay, there's a little flick. Set mode. 10 o'clock. We can set minutes. We can set seconds. All smooth working. What I do notice is sometimes when you put it back in the run mode, the seconds jump like that. But other than that, this thing's working very well. I do notice the two other B&Fs, the B&F clocks that I've had, do the exact same thing. So it's a behavioral issue of the circuit. Not necessarily this circuit, but the design in its entirety. Anyway, what else do we have to say about this? So I'll have to go through and clean up the connection points where the transformer connects, and right now it's just kind of tacked and botched together, but not how we're going to leave it. For now, this is where we're going to leave off. I do hope you enjoyed this video. More of these things hopefully to come. Thanks for watching. Checking the diodes. Reverse the connections. Open. They both behave the same. I think it's a voltage breakdown thing.